All right, later on your homework in this set, you're going to switch to Simpsons rule. So take the PowerPoint, go down until you find Simpsons rule, find this page, and notice the big thing that happens here is your coefficients change. So we did have 1, 2, 2, 2, 2, 2, 2, 2, 2, 1, and now we have 1, 4, 2, 4, 2, 4, 2. So the interior coefficients just change from fours to twos. It alternates. So it starts off with a 4, it goes to a 2, and then it goes back to a 4, then a 2, and then a 4, until it gets to the very next to last one, and then it's a 1 again. So it's 1, and it'll be 4s and 2s through the interior, the last one being a 4, and then it goes back to 1. Okay, there always has to be an even number of data points when you're going to do it. The n has to be an even number when you're going to do Simpsons rule. So n is 4 here, that's even, so Simpsons, we can use it. We can apply Simpsons rule. So let's modify the spreadsheet that we did before and make it apply to Simpsons rule. So this was the spreadsheet I made for the first ones. I'm going to change this. I call it trapezoid method. I'll just change it to numeric integration. And notice I got trapezoid method and I added a new sheet, Simpsons method. Now I'm just going to take what I have here, just Control A a couple times to get everything highlighted, Control C to copy, and then I'm going to take it to the Simpsons sheet that I've made and paste it. All right, now the big thing that's going to change here again is the coefficients. Okay, A, B, N, and delta X, the calculations for that are always the same. It's your starting point, your stopping point, and how many steps, what your step size is. Here we're going from -1 to 0. We want to do 4 steps, so that's a quarter. Notice it automatically changed all that stuff for me again. But I have a new function, so I'm going to do equals. It's now the sine function, the sine of, in Google Sheets to do pi, you have to write pi for pi. Open and close a parentheses, which is kind of weird. And then times t, a variable here is t, we're labeling it x, but that's fine. It's just your variable. Close the parentheses. All right, so there's that. I'm going to click here and drag down. So there's the values that I get. The coefficients, again, they need to change. This is now Simpsons rule. So it's going to be 1, 4, 2, 4. Just start off with 1, end up with 1. Start off with 1, end up with 1, and then inside it's going to be a 4, 2, and then the next to last one always has to be a 4. All right, so there's Simpsons rule. C times f of x. The last thing you have to do is change this approximate area calculation. It was delta x over 2, and notice now that it's delta x over 3. So we're going to change that 2 to a 3. And there's the approximate sum here. All right, let's check it with Desmos. We got a -1 on the bottom. We got a 0 in the top. This is now the sine of pi times x dx, or you can do t. You could switch it to t if you wanted. But you can see what we have here is -0.6366, and we've got -0.638. So again, it's not bad, especially for only 4 steps. Now, most of these always have 4, but I just want you to see that if I changed it, if I said, okay, let's do 16, delta x changes. Notice this no longer has 0. We're not going all the way to 0. It's because I haven't taken enough steps. So I need to drag this down until I see 0, or whatever the value of b is. All right, and if you go too far, it's not a big deal. You can either click this and drag it back up. That's one possibility of fixing that if you go too far. Or you can just click that and hit delete. All right, we need to go back up to the F column and drag this down far enough to where it evaluates all the values all the way up to 0. All right, and then the last thing we need to do is extend the pattern of the coefficients. So again, the last one needs to be 1. And in between, they need to alternate between 4 and 2. So 4, 2, 4, 2, all the way down. Again, as the formula says, the next to last cell, the next to last coefficient will always be a 4 when you're doing Simpson's method. All right, now the sum, this stuff right here will have to be moved. I may want to move it over to here. Actually, that would be a really good idea. I'm going to just format this to wrap. And I will drag the pattern of the coefficients all the way down. Okay, and now I'm going to say this is equal to I'm just going to write sum, open parentheses, and just click column D. Just click the letter D up there. And then the approximate area equals, same thing as we saw before. It's delta x over 3. I'm just doing this formula right here. Delta x over 3 times the sum. So it equals, find delta x, there it is, divided by 3 times, there's the sum above it now. All right, there's the exact area. I just pasted it from Desmos just to remind you, so you can see we're getting better. You know, the bigger n is, the smaller delta x is, the better your approximation of the area is going to be to the exact area. And just one last one, just so if I extended this to 32, I doubled it again, all I would have to do is go to the x column. Remember, my value for b is 0, so I would just need to drag this down until I saw 0. If I go too far, just select those, delete them, then go back up, make sure that F column and all the other columns go down to where that 0 is. So I'm going to just click here, drag down. Remember, the last one needs to be a 1. These need to be 4 and 2s all the way down. I can just copy that. I need to switch that to a 2, then paste. And there, the pattern extends down to where it needs to be. Again, you can always just manually type that in. All right, and then we want to make sure the coefficient times the f of x's extends all the way down to the bottom as well. All right, and once we have that, our sum and our approximate area calculation should be correct. All right, so we can see again, our approximation is getting very close to the exact area.